Friends, this is a discussion. This question says a wooden cylinder floats vertically in water with half of its length immersed. The density of wood is. So let us try to visualize the situation. So we have a container and it is full of water. And in this container, we have a cylindrical a wooden cylinder. So this make a wooden cylinder. And it is floating vertically in water with half of its length immersed. It means it should be little more high. According to my diagram, it should be little more high. The total height is h. Whose total height is h, and it is immersed half of its height. So h by 2 height is immersed inside the water and it is floating in this condition. Then we have to compare the density of wood with the density of water. So let us try to visualize what is happening here. So basically, if it is in equilibrium, it is not sinking, it is floating vertically. It means there should be some force which will be balancing this downward force mg, and we know that force is our buoyancy force, that is the fb. Both are balancing each other, that's why it is neither sinking nor going in the air. So we can write fb should be equals to mg, where m is mass of this cylinder. So we have to compare the densities. So we know that the buoyancy force is the weight of displaced fluid. Here we have weight of displaced water. So we can write rho water into volume of displaced liquid into acceleration due to gravity. This is the formula for buoyancy force, density of water or any fluid which is displacing, volume of displaced fluid, and acceleration due to gravity. Now we can write rho water into volume of displaced fluid into G should be equals to M into G. Now, how we can write the mass of this cylinder? So, mass of any body can be written as density into volume. This is the general formula, density into volume. So, we can write density, the density of the wooden material. So, we can write density of wood into volume of cylinder, the complete cylinder. Here we will take the volume of complete cylinder because we have to find the mass, and mass is available in whole of the volume. So we should write here density of wood into volume of cylinder into, this is the mass. These two things will give us mass into G, right? Let's try to simplify this. So G and G will cancel out. Now we can write density of water upon density of wood can be written as volume of cylinder upon volume of displaced fluid. Now, volume of cylinder. So, volume of cylinder should be pi r square into h. Volume of displaced liquid or water. See, here it is given that half of the cylinder is immersed in water. It means half of the total volume of the cylinder will be immersed. So, we can write 1 by 2 into pi r square into h, right? Half of the total volume, or we can write in another way, half of its height. So you can write as h by 2 also. Both are the same thing. Now, if you take the ratio, so you will get simply 2. So it means density of water upon density of wood will be equals to 2 upon 1. Now let us read the question, what we have to find. So we have to find density of wood. So density of wood should be equals to rho water upon. So the density of wood should be equals to half of density of water. So according to our calculation, the density of wood should be half the density of water. The B option should be correct. Thank you.